Welcome to our comprehensive guide on Apache Cassandra interview questions. Cassandra is a distributed NoSQL database that focuses on high performance and scalability. Today, I'll walk you through the fundamental concepts you need to master for your Cassandra interviews. These include distributed architecture, eventual consistency, data modeling principles, and high availability features. Understanding these core concepts will prepare you for technical discussions about one of the most powerful NoSQL databases in the industry. Apache Cassandra is a highly scalable and distributed NoSQL database designed to handle massive amounts of data across multiple commodity servers with no single point of failure. Unlike traditional relational databases, Cassandra excels at managing big data workloads across distributed systems. It provides high performance for both read and write operations, making it ideal for applications that require real-time data processing at scale. The database is particularly well-suited for use cases involving time series data, IoT applications, and systems that need to handle millions of transactions per second. Cassandra uses a ring topology where nodes are arranged in a peer-to-peer ring structure with no master-slave relationship. Every node in the cluster has the same role and responsibility, which eliminates single points of failure. Data is distributed across nodes using consistent hashing, where partition keys and hash functions determine which nodes store specific data. This architecture allows the system to scale horizontally by adding more nodes to the ring. The consistent hashing mechanism ensures even data distribution and enables efficient data retrieval across the cluster. Cassandra implements eventual consistency, which means data will eventually become consistent across all nodes, but may be temporarily inconsistent during updates. This approach prioritizes availability and partition tolerance over immediate consistency. Cassandra offers tunable consistency levels that allow you to balance between performance and consistency requirements. The one consistency level provides the fastest performance with least consistency guarantees. Quorum offers a balanced approach by requiring a majority of replicas to respond. All provides the strongest consistency, but at the cost of performance, as it requires all replicas to acknowledge the operation. Cassandra data modeling follows a query-driven design approach, which is different from traditional relational database modeling. The key components include key spaces, which act like databases, and tables that contain collections of data. Partition keys determine data distribution across nodes, while clustering keys control data ordering within partitions. The fundamental design principles emphasize denormalization as a normal practice, unlike relational databases. You should minimize partition reads for optimal performance and avoid creating large partitions that could impact system performance. Always design your data model based on your query patterns rather than normalized data structures. Creating tables in Cassandra requires careful consideration of partitioning strategies. In this example of a user profiles table, the user ID serves as the primary key, which automatically becomes the partition key. The table includes essential fields like email, name, and created timestamp. The with clause allows you to specify important table properties such as compaction strategy and garbage collection grace seconds. Size-tiered compaction strategy is suitable for write-heavy workloads, while the garbage collection grace seconds parameter determines how long deleted data markers are retained before permanent removal. Cassandra ensures high availability through robust replication and fault tolerance mechanisms. Replication creates multiple copies of data across different nodes, with the replication factor determining how many copies exist. Cross-data center replication enables geographic distribution for disaster recovery. The system provides automatic failover when nodes become unavailable. Fault tolerance is achieved through the absence of single points of failure in the ring architecture. Node failure handling is seamless, with hinted handoff mechanisms ensuring data consistency during temporary outages. Read repair processes automatically fix inconsistencies detected during read operations. Cassandra Query Language, or CQL, provides an SQL-like syntax for database operations, making it familiar to developers with relational database experience. Basic CRUD operations include insert statements for adding new data, select queries for retrieving information, and update commands for modifying existing records. CQL supports prepared statements using question mark placeholders for better performance and security. The syntax is designed to be intuitive while respecting Cassandra's distributed nature and data modeling requirements. Understanding CQL is essential for effective database interaction and query optimization. Cassandra excels in write performance through its append-only commit log architecture and in memory memtables that buffer writes before flushing to disk. Sequential disk writes eliminate the need for random disk access, while the no read before write approach speeds up insert and update operations. Typical write performance can reach up to 300,000 writes per second. Read performance is optimized through Bloom filters that quickly determine if data exists in SS tables, efficient SS table reads, and row-level caching mechanisms. Partition key lookups provide sub-millisecond latency for well-designed data models. To succeed in Cassandra interviews, master these fundamental topics. Understand the distributed architecture and ring topology concepts, grasp consistency models and how they relate to the CAP theorem, learn data modeling best practices for NoSQL environments, know performance optimization techniques and tuning strategies, comprehend replication mechanisms and fault tolerance features, and practice CQL queries and database operations. These topics form the foundation of Cassandra expertise that interviewers expect. Focus on understanding the practical applications and trade-offs involved in each concept. Master these fundamentals to excel in your Cassandra interviews and demonstrate your expertise in distributed database systems.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.